This is Algebra 1, Lesson 10-14, Solving Quadratics by Using Structure. Today's date is Tuesday, April 28th, 4/28, 2020. Our objective today is to use substitution to rewrite and solve quadratics in a simpler form. So let's jump right into it. You have a problem that looks like this. We're trying to find all the solutions to the equation. It's basically just saying solve. And it looks hard, it looks gross. So how are we going to approach this? I notice that there's this common x squared minus 33, x squared minus 33, and that's kind of the thing that's making it hard. So I'm going to use substitution. I'm going to say okay, I can choose any variable that I want. I could use star, smiley face. Khan Academy uses p, so I'm going to do that as well, just so that if you look at their hints or their solutions, it'll look similar. So I'm going to say this p is going to contain x squared minus 33. If I do that substitution, if I rewrite this equation, it will look like, okay, well, this entire thing now is p, so I'm going to write p squared plus 5 times p, so plus 5p, and then minus 24. There's no substitution that I can do there, so I'm just going to leave it as minus 24, and say that's equal to 0. Okay, well, that's a much simpler quadratics to solve, and we've seen how to do that before. So let's go ahead and do an advanced ninja star, or not advanced ninja star. There's a leading coefficient here of 1, so a normal ninja star off to the side out here to help us. What two numbers add to 5 and multiply to negative 24? Go through all the factors of 24. 1 and 24, no. 2 and 12, no. 3 and 8. Oh yeah, 3 and 8 will probably get 5. So 3 and 8. That means 5 is positive, so the bigger number should be positive. The negative should go with the 3, and everything checks out. So this is now going to factor as p minus 3 times the quantity of p plus 8, and that's still being set equal to 0. And then I solve. So using the zero product property, I'm going to say that this p minus 3 is equal to 0, and this p plus 8 is equal to 0. Adding 3 to both sides on this left equation gives us p is equal to 3. Subtracting 8 from both sides of the equation here gives us p is equal to negative 8. And you would think you're done, but now you have to go back and say, okay, well, what is p? This p and this p are the same p, which means I'm going to plug this x squared minus 33 into that variable p to do an additional last step. So what does that look like? Well, now I say that this x squared minus 33, I can't write there, minus 33 is equal to 3. And similarly over here I have x squared minus 33 is equal to negative 8. So what am I going to do to solve on this left side? I'm going to add 33 to both sides. So if I add 33, that gets rid of that 33, and I'm left with x squared is equal to 36. I could solve, but I'm going to do the right equation now. I'm going to add 33 to both sides, and I get x squared is equal to, it's going to be positive 33 minus 8. I think that's 25. And these are nice problems now, and I ran out of room, so I'm going to come back up here. My next step is to square root both sides. So if I do that, I'm left with x is equal to plus or minus the square root of 36 is 6. And for the second equation, square root both sides, x is equal to plus or minus 5. And those are my answers. So if I listed all of those answers out, I would have negative 6, negative 5, 5, and 6. There are 4 different answers in this case that work for this equation. And on Khan Academy, you can list any one of those. So it says give one answer, and you can just choose either one of the 4. Let's try another one. Example number 2. So find all solutions to this equation. It's a little bit different because it's not too clear what I should be substituting out. In general, you should be substituting out the thing that looks the most complicated, and usually the thing inside parentheses. So I'm going to let p in this case equal this 3x plus 2. That looks complicated to me. So if I say p is equal to 3x plus 2, and I'm going to go ahead and rewrite this thing. So what's going to happen here, I can actually factor something out. So if I treat this as kind of 2 segments, I have this negative 6x minus 4 as a separate problem, and I can factor out something from 6x minus 4 to make it look like 3x plus 2. I'm hoping that you can maybe see where I'm getting at here. So I can go ahead and rewrite this as p squared, because that's p right here squared. And now I'm not going to do any p substitution yet. I'm going to simply factor out the greatest common factor in this blue rectangle, and the greatest common factor here is 2. So I'm going to factor out a 2, and to make it a positive 3x and a positive 2, right now they're both negative, I'm going to factor out a negative as well. So I'm going to say I'm going to factor out a negative 2. And when I factor out a negative 2, negative 6x divided by negative 2 is just positive 3x. A negative 4 divided by negative 2 is positive 2, so I say plus 2. And now, again, I can say, hey, 3x plus 2, 3x plus 2, that's just p. And by the way, this is still set equal to 0, so I'm going to come down here on the next line and say p squared minus 2p is equal to 0. And then it's just kind of solving like we did before. So in order to solve this one, I'm going to factor again. So what's the greatest common factor of p squared minus 2p? Well, I can factor out a p. So if I factor out a p times quantity of p minus 2 is the same thing as p squared minus 2p, and that's set equal to 0. Using the zero product property, I'm going to say that this p is equal to 0, and this p minus 2 is equal to 0. And adding 2 to both sides, that means p is equal to 2. So again, like the last problem, we're not done. We need to solve for x. That's the original equation only had x. They don't know what p means. So I'm going to rewrite this left equation. It used to be p is equal to 0, but p is 3x minus 2, so this 3x minus 2 is set equal to 0. So I'm going to say 3x minus 2 is set equal to 0. That's the left equation. And I think I accidentally undid too far. This should be a 2 right here. And then finally, I have on the right-hand side, I have the same 3x minus 2 is set equal to 2. Okay, and then from here, I'm going to solve yet again. So I'm going to add 2 to both sides. So 3x is now equal to positive 2. Add 2 to both sides. 3x is now equal to 4. I'm going to divide both sides by 3, and x is equal to 2/3. And over here, divide both sides by 3, and x is equal to 4/3. And those are my 2 possible answers. I'll box both of those. All right, let's try example number 3. This one is the easiest type of all of them because you don't actually need to solve. It just says write an equation, and then it should say in the instructions maybe to make it clear, but don't solve this. Just use the substitution. So it even tells you, hey, I know what the value of p is. It's going to be x squared minus 3. So this x squared minus 3 is p. So I'm going to start rewriting. This is going to be p, that's it, p squared plus 13. I can't do anything with that 13 yet. Ooh, okay, so this 3x squared minus 9, the whole idea behind doing p substitution is to get rid of all of your x's. So I need to somehow get rid of that x by substituting it out. So, okay, I can factor out the greatest common factor of this right side. So what's the greatest common factor of 3x squared and minus 9? I think it's 3. So if I factor out a 3 on that right-hand side of the equal sign, factor out a 3, 3x squared divided by 3 is just x squared. Minus 9 divided by 3 is minus 3. And hey, yet again, I have an x squared minus 3, which is the thing that I'm going to be substituting out for p. So I can now rewrite this thing as p squared plus 13 is equal to 3p. And I'm done, but on Khan Academy, typically they like the right-hand side equal to 0, so you could stop right here and you're done. But I'm going to go one step further, and I can say I'm going to subtract 3p from both sides, and I get my final equation as p squared minus 3p plus 13 is equal to 0, and I'll box that one. Cool. That's all I have for you guys. That concludes Algebra 1 Notes 10-14. I'll see you guys tomorrow.